The goals for the second generation Eurocode standards have been set very high, improving ease of use, deepening harmonization, enhancing the lifespan of existing buildings, incorporating structural glass, to name just a few. What has been achieved today, and when can we expect the second generation standards to be published? Steve Denton, the chair of CEN/TC 250, has an overview for us. We're looking forward to your speech.
Thank you. Thank you very much. Well, good morning, everyone. It's a real pleasure to be here. It's really nice to see people in person and also to see people online. So as I said, it's a pleasure to be back in Germany, a pleasure to be in Berlin, a pleasure to be back at DIBt, and I wanted to start by thanking everyone who's been involved in organizing this tremendous event. So thank you very, very much on behalf of TC 250. So my job this morning is to give you a little bit of an overview, an introduction to what is happening with the transition to the second generation of the Eurocodes. And I'm joined today by all of the subcommittee chairs who will provide the technical details around what is happening with the evolution of the Eurocodes. So I'm going to start off with a little bit of background, and then I want to take a little bit of time to talk about why design standards matter. I'm then going to talk a little bit about the aims for the evolution of the Eurocodes, and then finally talk a little bit around the program, where we are today, and what the next steps are. So by way of background, I think it's appropriate that I give you a little bit of my background to start off with. So I'm the chairman of CEN/TC 250, but my day job is as the head of civil and bridge engineering for WSP in the UK. And WSP is one of the world's largest engineering consultancy businesses, and the unit that I lead in the UK has about 650 staff. So my primary role is as a practitioner, and I bring that perspective to the work within TC 250. But I also am a visiting professor at the University of Bath. I've been advisor to clients and governments around standardization for over 2 decades. So I try and bring all of those different perspectives to the work of TC 250. So this is the structure of the second generation of the Eurocodes. The standards that many of you will be familiar with, running from EN 1990 through to EN 1999. The most observant within you will notice that we have 3 new additions in the second generation of the Eurocodes, TS 19100, 19101, and 19102, covering structural glass, fiber polymer composites, and tensioned membrane structures. And those are currently at TS standard, TS level, but on a pathway to achieving EN status. And the way in which TC 250 organizes itself is that the responsibility for those standards rests principally with our subcommittees, and that's why it's such a pleasure that all of the subcommittee chairs are going to be speaking to you today and explaining to you what is happening specifically with each of those Eurocode parts. So why do design standards matter? The speakers so far today have talked a little bit around the importance of standardization, but I wanted to share with you some of my perspectives on this. The first point I want to make is impact. You know, the Eurocodes are used by over 500,000 engineers across Europe and around the world. You know, it's something that we talk about within TC 250. That work we do, those decisions we take in those meeting rooms across Europe, it's easy to get focused around the kind of minutiae of what we're putting on each page and forget the impact of it. And it's so important that we always remember the impact of the decisions we take. The second characteristic that makes design standards so important in the construction sector is that what we do in the construction sector is typically at a scale which means it's very difficult to test prototypes. In most branches of engineering, lessons are learned in labs and factories, but in construction, we tend to learn lessons on real live projects. And what's crucial is that before something is built, we need a means by which we can verify the adequacy of our design. Design standards fulfill that role. They enable us to confirm that our designs will be safe, serviceable, durable, and robust before they are built. And that's a fundamental need within the construction sector. Perhaps making standards more important in the construction sector than they are in probably any other branch of engineering. One of the other characteristics of the construction sector is it's quite fragmented. You know, I often contrast it with other branches of industry where I think, for example, in automotive, where organizations have a link through from conceptual design to the maintenance of vehicles. And I imagine that when lessons are learned, there's a thread through those organizations that enable those lessons to be learned. If there was a recall on a product, I'm sure that's felt in all parts of those organizations. Because of the fragmented nature of the construction sector, learning those lessons is harder. And standards play a really important role in that. Standards are one of those vehicles by which we can collectively learn lessons. And we know that's true because when we look back in history at when there's been major incidents, for example, they've often been the stimulus for activity to update and improve standards. As we've already touched on this morning, embracing new societal demands, standards have a key role in embracing new societal demands, and particularly in connection with the second generation of the Eurocodes, matters around sustainability, climate change, have been things that we have discussed, thought about deeply, and tried to improve the provisions within the standards to support the new societal expectations in these areas. And then finally, that passage, enabling that passage from research through to application. And here, standards, I think, play two roles. Firstly, they set a framework that enable researchers to have a baseline for the work that they're doing. But also, once research has reached a sufficient level of maturity, once it's been supported by a sufficient level of practical application, then it can find its way into the standards. And through that, that research work is made available, is opened up to thousands, hundreds of thousands of engineers to use. And so for all of those reasons, I think standardization, design standards are important, particularly important in the construction sector, and therefore that's why the work of TC250 is so vital. So then let me move on and talk a little bit around the aims for the evolution of the Eurocodes. So when we embarked on this program, which is probably the largest standardization program in European history, certainly by funding levels from the European Commission. When we embarked on this, we set ourselves two key overarching objectives. The first is that we wanted to enhance ease of use. Now, the achievements in developing the first generation of the Eurocodes were outstanding, but there was feedback that the usability, ease of use could be enhanced, and that has been a primary focus across all work on the evolution of the Eurocodes. And the second objective that we set ourselves was that we wanted to achieve exemplary levels of international consensus. And in terms of those exemplary levels of international consensus, of course, the processes within the standardization community, the final step is to have a formal vote where the 34 countries who are members of CEN get to vote on whether they are happy with the work in the end. So we have a very clear measure of how well we have done in terms of achieving strong levels of consensus. And what I want to do now is just to talk a little bit about the steps we've taken, the approaches we've taken to try and fulfill these aims for the second generation of the Eurocodes. So firstly, in terms of enhancing ease of use, so one of the first things that I did when I became chair of TC250 was I set up an international panel. It had 16 members, and that panel consulted widely across Europe to define what we meant by enhancing ease of use and to develop recommendations for how we should work to enhance ease of use with the second generation Eurocodes. And Gerhard Breitschaft led that panel that did that work. And that panel produced a really, really important document, an extract from it here, that has really underpinned and shaped the way that we've approached the evolution work for the Eurocodes. And as it says here, whilst respecting the achievements of the past, the vision for the second generation of the Eurocodes is to create a more user-orientated suite of design standards that are recognized as the most trusted and preferred in the world. That's the target that we set for ourselves. And to put that into practice, we established 5 pillars to support that, putting together statements of intent to meet users' needs, setting principles and priorities, providing examples for the thousands of people engaged in the Eurocode developments, looking at measures to try and understand how we were progressing, and then putting in place appropriate management, governance, and support. So digging into these a little bit more deeply, in terms of those statements of intent, the users, one of the first things we did also was to look at all of the different users of the Eurocodes to understand the diversity of users of the Eurocodes, but also to recognize, which I think is vital whenever you write any document, is to have in mind who is your primary audience. So we defined our primary audience for the Eurocodes as practitioners and competent engineers. That definition, competent civil, structural, and geotechnical engineers, typically qualified professionals able to work independently in relevant fields. And again, it took a little bit of time to arrive at that definition, but I think it served us very well. Because as you can imagine, there have been thousands of experts across Europe involved in the evolution of the Eurocodes. And it's challenging to make sure that everyone works to a common baseline that understands those shared objectives. And having these kind of definitions so that we, whenever we're working on a document, we can think, well, does this fit for our primary audience? That's a really, really important thing for us to be able to do. But we went further than that to recognize that we do have a lot of other users, and we mapped them out, and we prepared statements of intent for each of those groups of users. So for our primary audience, we set ourselves that objective of saying we will aim to produce standards that are suitable and clear for all common design cases, but crucially without demanding disproportionate levels of effort to apply them. Or for expert specialists, aim not to restrict innovation by providing freedom to experts to apply their specialist knowledge and expertise. And there are, in developing standards, some very practical things that we can do to enable that. For example, in the selection of the verb forms that we use of whether a clause is a requirement, a shall clause, or a recommendation, a should clause, or a permission, a may clause. But going further, for educators looking to have consistent underlying principles, or for regulators to produce standards that can be referenced or quoted in national regulations. So we set ourselves those set of statements of intent. We also set ourselves a set of principles and priorities. At the top, around improving clarity and understandability. Second, improving accessibility, ease of navigation. And again, these have served us very, very well in the discussions around the evolution of the standards. And sometimes what we find is there are some tensions between these. If you look down through that list, you can imagine that there will be situations where they can pull a little bit in different directions. But the value of having them documented has meant that when we have those conversations from a common understanding, from a common framework. And then what we've also put in place were those other 3 pillars around guidance and management, support and measurement. The appointment of our technical reviewer, the Eurocodes, has been a really important step. So every single one of the drafts has been reviewed by Mary Pierangelino in her role as technical reviewer, or by Michael Fardis, my vice chair, former vice chair. You know, everything has been scrutinized, but scrutinized not just within the experts in that field, but to look at the interdependence and across the whole suite to try and achieve consistency as well. So that detailed review of deliverables, sort of guidance documents that we've put together, providing examples and advice and training for everyone that's been involved in the work. So that's how we've looked to embrace that first aim, to enhance ease of use, and then the second, to achieve exemplary levels of international consensus. My role as chair of TC250, one of them, is set out in the CEN internal regulations, and it says that my job is to do everything possible to obtain a unanimous decision, but if unanimity on a subject is not attainable, the chairman shall try to seek consensus rather than rely on a simple majority. And I remember when I first read this in the CEN internal regulations, probably about 14 or 15 years ago. And I'm not sure at the time I really understood what it meant, because if you've achieved consensus, have you not got unanimity? But I've learned a lot over the last decade or so. And I think one of the key things that I've learned is that, consensus is not so much about the outcome, but about the journey that you follow to get there. And that, of course, what is consensus? Consensus is not arriving at a destination which is every person's top preference. You can't always achieve that. People come into this work with different perspectives, different priorities. So we can't always achieve everyone's top preference. But what we need to do is to try and arrive at an outcome that everyone can stand behind. And that's what it means to build a consensus, an outcome that everyone can support. And that's one of the reasons why it takes time, because going on that journey, having those conversations, understanding one another's perspectives is such a fundamental part of consensus building. And again, we've discussed this and spent time thinking about this within the TC250 family and put together a position paper for how we should work together to achieve that consensus, which was itself unanimously supported across all of the CEN members, to the point of defining a process, a 5-step process we should follow when we identify points of issues, of disagreement. Because of course these will happen. Of course these will happen. And I think one of the things that I've learned is that it's easy when you look at points of disagreement to think that they arise because one person is right and someone else is wrong. In my experience, that's almost never the case. In my experience, what I've seen is the reasons why people have different viewpoints is because they view issues from a different place. The reason why people have different answers in mind is not because they're answering the same question differently, it's because they're answering different questions. It's because what they bring are different educational backgrounds, different local customs and practice, in the geotechnical world, different predominant ground conditions. And actually, when you identify those differences and when you take time to understand them, then you can arrive at a consensus position which is much better than it would be if you don't take the time to understand those different perspectives. And so for me, it's been a fascinating and often kind of profound experience to see how we can work collectively and how we learn from one another and how we can arrive at those consensus positions. And there's still a way to go. There's still a way to go. But I think one of the things that pleases me most about the work we've done within TC250 is that under my chairmanship over the last decade or so, we have taken hundreds, somewhere over 400 decisions within TC250, in which 34 countries have all been able to cast a vote. And over that whole time, we have had probably fewer than 20 negative votes from any country on any one of those decisions. And I think that just shows that the effort that people have taken to try and reach those consensus positions. So that's a little bit about how we've approached the work. Let me finish by just talking a bit around the program, the status, and the next steps. So a little bit of history. A really, really important step in the evolution of the Eurocodes was when the European Commission released a CEN mandate M515. A mandate is a mechanism by which it is possible to derive some financial support, and that was really important for us. But it set out, crucially, it set out the ambitions, expectations from the Commission for how they wanted to see the Eurocodes evolve. And we responded to that, and we had over 1,000 experts involved in putting together our response to this, a programmatic response for how we could meet the requirements of the mandate, and as I said, with a programmatic approach, 4 phases of work. For each of those phases of work, we had a series of tasks split into subtasks, all properly defined, and that led to the formation of project teams, had international calls for those project teams, and so through those project teams, again, we had somewhere over 250, 300 experts who were working in dedicated project teams of 5 or 6 people, supporting the evolution work, and then that being overseen by that framework of subcommittees, working groups, actually over 100 subcommittees, working groups, task groups within the TC250 family. The stimulus for the evolution work was not just what we received in Mandate M515. What we also did at the start of this program was undertake a comprehensive systematic review where every CEN member had the opportunity to comment on every one of the existing Eurocodes and to provide their feedback on how the Eurocodes could be improved. And then that, if you like, that top-down perspective within M515 was combined with that bottom-up perspective from the systematic review to drive the evolution of the Eurocodes. And so what's changing? There are changes to all the existing Eurocodes, and you'll hear a lot about that today. The extension of the scope to cover structural glass, fiber polymer composite, and tension membrane structures, and some common themes, looking to strengthen the coverage of robustness, extending the scope to include aspects of the assessment and retrofit of existing structures, looking at climate change, and I'm sure Nick, when he talks from an SC1 perspective, will no doubt talk a little bit around how we're looking at including coverage of climate change within the treatment of environmental actions. And then that underlying piece around improving ease of use, as I've already mentioned. And in terms of the program, the timeline, so this runs through a little bit of the history, going right back to the development of the first generation. And as I mentioned, the work on the development of the second generation has been undertaken in 4 phases of project teamwork. All of that's now concluded, that project teamwork. And now we're really at the business end of things, as Gerhard's already said, where we have the documents going through the processes of inquiry and formal vote. There are defined steps that we take with this. They're important. So each of the documents, once it has reached a sufficient level of maturity, goes through a process of translation and editing and then a formal inquiry. And that inquiry provides the opportunity for all of the CEN members to comment on a clause-by-clause basis on every one of the documents. And then those reviews are received by the responsible subcommittee, and they're obliged to go through comment by comment and provide a response to every single one of the comments we receive, sometimes thousands of comments, and then to produce the final version of the standard, which goes through the formal vote process that I mentioned earlier. And where we stand today is sort of partway through this. We have some documents that have already gone all the way through to formal vote. We have others which are approaching inquiry. It's useful, perhaps for me to just share briefly a couple of kind of slightly technical terms because they may come up later today. So one of those is what's called the date of availability of a standard, and that's the date when CEN, the European standardization body, releases the documents to the national standardization bodies, and the date of withdrawal, which is the date by which conflicting national standards have to be withdrawn. And in the Eurocode context, the conflicting national standards would be the first generation Eurocodes. And what we recognize, because the Eurocodes are obviously an interdependent suite of standards, that we can't treat these in isolation. You couldn't have different dates of withdrawal for different standards within the suite. That could lead to quite a confused picture. So we have a common date of withdrawal that's been defined for all of the second generation Eurocodes. So the way in which this is going to work is that right now, We have got documents that are going through their inquiry and formal voting process. Some already have been made available to national standards bodies, meaning that at a national level, national annexes can start to be developed. And what we are doing at the moment is working really, really hard. All of the subcommittee chairs know this, working incredibly hard to hit our target, which is that the last formal vote for the second generation Eurocodes will take place in October 2025, which will mean that all of the second generation documents will be available to national standards bodies by March 2026. And then there will be a period of 2 years to March 2028, so that by March 2028, at a national level, the first generation Eurocodes will need to have been withdrawn. Now, the decision on how to manage that transition is obviously a national decision, and countries could choose to go quicker than that if they wish to, or to have some kind of phased transition. But what this does do is give us a common basis that we have got that data withdrawal, March 2028, and on that date, the expectation from CEN is that all CEN members, all national standards bodies will have withdrawn their first generation Eurocodes by that date. And just to finish, where we sit today, so this is our program. The people who've been working with TC250 will know this very well because we spend lots of time looking at this. We've been tracking this really closely with all of the Eurocode parts, moving through all of the phases of preparation for inquiry and formal vote. And we sit here today, so you can see today we've had quite a number that have gone through formal vote, which is towards the end of the process. The inquiries, the yellow blocks, we're more than halfway through the inquiries, and the final block of inquiries is going to happen for the second generation documents early next year. So roughly, in terms of those inquiry and formal vote processes, we're probably past halfway. So we're a significant way down the track. We have a lot of very mature documents. We still have quite a lot of hard work ahead of us for the next couple of years. And again, this is where we sit in terms of looking ahead to the inquiries and formal votes. So as Gerhard rightly said, the timing of this conference, I think, is ideal. The documents are at a very mature state, but still going through those processes of inquiry and formal vote as we work to try and fulfill the aims that we set ourselves for TC250 of enhanced ease of use and achieving exemplary levels of international consensus. And with that, let me wrap up now and hand over to the rest of the speakers. Thank you very much.
Thanks. Thanks to you, Steve. Thank you for this inspiring look behind the scenes. I'm quite sure many in the audience are burning to ask you questions, and we do have a question and answer session at the end. So for now, let's continue. For those who are joining us remotely, you can start sending in your questions, of course. For now, let's continue with the first two standards in the Eurocode ceilings, dealing with the basic principles of structural design and actions on structures. First up is Paolo Formichi with his talk on EN 1990.
Thank you. Thank you very much. It's a great pleasure for me to be here today, and want to thank you very much, Gerhard and DIBt, for arranging this important conference. Great pleasure for me to be here because we took in our subcommittee quite a number of important decisions right in this room. So DIBt has always been cooperating with us a lot. I will be speaking about basis of design, and I will give just some highlights on the revision process under the mandate 515, And I'll try to give some focuses on what we've done and what is changing in basis of design in the second generation in the second part of my presentation. So let's get started then. This is the standard which is currently in use. It was first published in 2002. And immediately after that, in 2005, as you know, there was a publication of an amendment to include the bridge-related parts, Annex A2, dealing with the basis of design for bridges. But after 5 years, according to the CEN rules, they started with the inquiry, with the 5 years inquiry and the first revision of 1990. And that work was very important because it was the start of the identification of the needs for the future changes in 1990. And there were basically two set of needs. The first one is a short-term revision, which was incorporated by Corrigenda in 2010, mostly editorial changes. But the second one, very important, is the set of the medium to long-term technical revisions. And these were the basis for the answer and the replies to the mandate that Steve just mentioned, and we were started working on these bases with a number of tasks attributed to our subcommittee 10, where we work with 2 project teams, with 3 working groups and 1 hot dog group, quite a number of experts involved. And you see here, we have divided our work in 3 big packages. We call them Package 1, which is the main text of basis of design, and the number of annexes we all know in the current version of the standard. Package 2A is dealing with bridges, and we merged these 2 packages in the inquiry process, and we went through these. We started in 2016. It's more than 6 years that we work on this, and we collected more than 5,000 comments, technical comments on these drafts going on, and that, I think, is a value for our work. But the good news is that in December last year, we got a 100% positive vote, formal vote for this Eurocode. So we now have Eurocode in 1990 with formal support of all member states. And then we have Package 2B. Well, we will see it here in the next slides. It is coming, and the formal inquiry on that will start March next year. Well, this is the, for me, is really overarching illustration of the new things in basis of design. We start from one document. We have basis of design now. We will have 2 documents. We will have part 1 devoted to new structures and part 2 for the assessment of existing structures. And this is also in line with what we've heard about the attention on the reuse of existing buildings and bridges and other structures. If we look at the architecture of the documents, and we start from part 1 on new structures, you see here that in terms of enhancing ease of use, what we have tried to do is to clearly subdivide the text in blocks, logical blocks. So you first have the main text, and the main text is something that, as we say in SC10, you at least once in life you have to read. Everything is in there, the details are there, but for the daily use, what you need to read is the annexes A. So if you're designing buildings, you're interested in reading Annex A1. But you will see that there we have some new annexes. For example, if you're designing towers and masts, you will have new Annex A3 and so on. Then we have another blocks of informative annexes with more specific specialist informative information, supplementing the main text with more specific guidance on aspects, such as, for example, you see Annex B, the management measures for design and executions. Then you have a new annex on robustness, which was debated at length in our work. So this is informative, but this is there to assist users in decoding the main text on these aspects. And then finally, a last block is about more specific aspect to do with design of bridges, the design of bridge bearings, and so on. This is the architecture of the part 2. It's completely new, as I said. It's a main text where you will find 12 clauses. And there is an annex, again, informative, to provide additional guidance to implement this. I drew your attention on the fact that we have, well, the same structure as the other Eurocodes, but we have the assessment scope and objectives, important section on the basic variables, and they are updating for the assessment of existing structures, which is key aspect in that job, structural modeling, and so on. So now let's start digging a little bit more deeply in the key revision aspects. I tell you, it's something that I tried to put together, but due to the time constraint, it's impossible to squeeze such a long work into a short presentation. I hope that this at least will raise your attention and your curiosity to go and read. But first of all, the very first innovation is in part one, is from the title. You will recognize that this is now basis of structural and geotechnical design. So what we have done, we have incorporated a number of overlapping issues that were in the first generation, and we've taken from 1997, and we have now a full and comprehensive set of basis of design rules applicable to the design of geotechnical structures as well. And to us, this is a very important achievement in terms of enhancing ease of use, because basis of design is in basis of design. Consequence classes. This is another important innovation. We now have 5 consequence classes instead of the classical 3 of them. We have added a consequence class CC Note and the consequence class CC4. And you see that the definition of the consequence classes is now given in terms of qualification, general qualifications, ranging from very low to extreme, or in terms of loss of human life, or economic or social consequences, from insignificant to huge. And the definition and the detailed definition of what is belonging to what is given in the different annexes, Annex A 1, 2, 3, 4, and 5, and so on. The Eurocodes are still applicable for the 3 central classes. So in this nothing new, I would say. But what is important is that the addition of the 2 new classes is now really helping us in finding the Eurocode's extension of scope. For example, the CC Note is extremely relevant because CC Note are those elements which are not relevant in terms of consequences, but which can be designed according to the Eurocodes. They are the so-called non-structural elements, which is a nice word but impossible to define. And CC4, at the same time, they can be designed according to the Eurocodes, nuclear power plant, for example, but some other and additional instructions may be needed. 3 years discussion about robustness. Well, robustness is a very relevant concept. Steve mentioned that this is something horizontal issue across the Eurocodes. And, well, robustness is defined as the ability of the structure to withstand unforeseen adverse events without being damaged to an extent disproportionate to the original cause. But what is really important here is that in this paragraph you see on robustness, we have acknowledged that there is a 2-level approach. Robustness is one of the principles, of the requirements that we need to meet for the design of new structures, but we will see also for the assessment of existing structures as well. And in general, and you see that note 2 there, for most structures, design in accordance with the Eurocodes is assumed to provide an adequate level of robustness. So this is the very first important achievement of our discussion, I would say. And if needed, and when this is needed is established by the national competent authority or by the client, or by needs related to the specific design, well, something more is to be done, and this is according to measures to enhance structural robustness. And these measures are outlined in one of those informative annexes, Annex E, a new one, giving some strategies and design measures to enhance structural robustness. In the discussion we had, and I will not go into the detail of Annex E, but just want to show you this table, because this is a result of a very long discussion, and to us is a very important point. We have clarified that robustness is normally the result of a set of activities. It can be the result of designing for accidental actions, but this is our normal engineering verifications. So you have an action and you have a resistance and you compare. And this is what is given by the left-hand side of the table. So you go in 1991, you take the actions, the accidental actions, and you do your verification. Nothing new. But this is providing robustness, but not the enhancing robustness as is intended in basis of design Annex E, which is the right-hand side of the table. These are other strategies. You may provide alternative load paths. You may design key members to resist notional actions, or you may have segmentation of your structure in such a way that the collapse of one part does not affect the others. And all these strategies are defined and are specialized according to the different levels for the consequence class. And everything is written in this new Annex E. Another important innovation is attention to sustainability. More and more this is relevant, as we have heard. And we have this requirement to reduce the use of non-renewable environmental resources, which is extremely difficult to be codified in a design standard. But what is important for us is that through this clause we have set a principle. This is a basic principle which can be achieved also by instructions which can be given clearly in the national annex. And you see that in the note we're opening for further specifications to be given in the national annex on that. Standards are normally, we have a lot of requirements, a lot of performance requirements. We have reliability, durability, and so on, but it's on paper. And we need to make sure that everything is transferred into the real world, into the building or into the bridge. How do we do that? Well, implementing appropriate quality measurements, management measures. And this is codified in the main text. So this is clearly given here that should be implemented to provide a structure that corresponds to the design requirements and assumptions. And this should be dealing with procedures in design, execution, use, maintenance, and so on. And again, how to achieve that is given in one of those informative annexes. And in particular, this one is the new Annex B, which is providing instructions on how to achieve these technical management measures for design and execution. And you see that this is defining 4 levels of activities, 2 of them dealing with the design stage, so the qualification of designer, first of all, and the checking of the design. And after, the latter are dealing with the execution phase for the execution quality, and this is related to the execution standard, for example, 1090 for steel structures, or inspection during execution, how to implement inspection procedures during execution. This is a framework annex, because we're not giving the general rules for the qualification of designers. This is clearly something to do with the national legislation. But in this framework annex, we set exactly a framework, how to use this information and how to implement this level of inspection and design qualification and so on. And in the end, everything is summarized by this table, which is linking to the consequence class of your structure the minimum level of qualification of designers, checking level of the design, the execution, as we said, is related to the execution standards, and the inspection level defined for the different classes. Let's have a look at one example of the annex, the operational annex, those for everyday use. This is Annex A1 for buildings, and this is one big table with all partial factors. Now, when I start my job as SC10 chairman, I got a comment that everything we need from you is combination rules and partial factors, which is a little bit, maybe it's not really what is needed. But clearly this is one of the most relevant part of the document, these partial factors that we use in combinations, that we use every day. At first sight, it looks complicated. I can promise you that it takes 5 minutes to read it, together with the notes, but everything you need is here. So for whichever combination you're dealing with, the partial factors are all given here. And you notice that we have verification cases now. We do not have more the STRA, GEO, and so on. But it's made clear by means of the notes and the text before the table. And you just pick up your partial factor from this table if you're structural resistance verification or if you are in a geotechnical verification. So again, 5 minutes to read it the first time, and we hope much easier to use in the future. This is, by the way, substituting the 3 tables that you remember we had in the annexes in the first generation. Another important innovation is about serviceability criteria. In the first generation of 1990, there were only recommendations to meet serviceability criteria for buildings and bridges, but there were no suggestion, no recommendations for limiting for example, vertical and horizontal deformations and so on. What we have done is that we have collected all the values and all the limitation in use in the different countries. There was another group active in this in SC10 for specific purpose. And we have put together all the best practice that we collected in the different countries for these three areas: vertical and horizontal deformations, vibrations, and limiting foundation movements. And we ended up with a set of recommendations which are independent of the material, as it is basis of design is material independent. So what you will find is just an example for vertical deflection. You're familiar with the figure. It's taken from the existing standard. Is the different components of the deflection of the horizontal member. But you will find a table, which is an NDP, providing you, depending on the nature of the limit state you're checking, if it is governed by the characteristic combination or the frequent or the quasi-permanent combination, depending on the reversible or irreversible nature, you will find the limitations suggested here in this table. And the hope is that we can use this table to harmonize the limitations in the future in different member states. For example, if you're designing a beam in a floor, and your internal partition walls are not reinforced and fragile and so on, you will find that the limitation is L over 500, for example. This is a recommendation to be confirmed as an NDP. Something similar is given for horizontal deflection, and an approach for vibration as well. But another innovation is the one on the limiting foundation movements. This is, again, completely new in the standard. We have focused the attention on three important foundation movements which can lead to the result of ultimate limit state or severe serviceability limit states out of the number of foundation movement described first by Berlin and Rhodes in 1975. We have focused the attention on the differential settlements, delta S, the tilt, omega, and the relative rotation, so the angular distortion, beta. And how it is managed. Buildings are classified into different structural sensitivity classes, from 1 to 5, so from the lowest to the highest sensitivity, and according to the classification in the sensitivity class, you will find, again, as an NDP, but recommended values of limitations for all of these different foundation movement limits. This is something more specialist, Annex C. It has always been specialist for users. It's reliability analysis and code calibration. What we had as a feedback from the first generation was that this was considered to be an annex a bit more theoretical. But this annex is a core part of the standard because it provides the values of the beta targets, so the reliability targets that we want to meet by means of partial factors or other methods of calculation of our structures. So we tried to make it more readable for users, and in particular what we did is clearly a distinction between two parts of this annex, which are the basis for reliability analysis and partial factor design, which is for users, is for those who are intending to apply the reliability-based methods. So here you will find instructions, you will find the agreed methods to be used. And the other one is for national standard bodies because it provides guidance on the calibration of partial factors, which is something which is not for users, of course, but we need to provide a common guidance for that as well. And you see here, this is the table with the beta targets, which are the recommended value, no change with respect to the previous edition. They're given in terms of 1 year or 50-year reference. Importantly, we have related also in the 50-year column also the corresponding approximate value of the probability of failure in 50 years. So you see that the idea is to have one order of magnitude difference in different consequence classes. And another important work that we have done in SC10 is to provide a JRC technical report. We have worked a lot on this, and there was a team of members, of experts coming from all subcommittees. And this will be made available, we hope, in the second half of this year. And, well, it includes the the background, so the history, what is behind the semi-probabilistic verification method, and also for the guidelines for the implementation of the probabilistic and risk-based methods, and importantly, the annexes, in particular Annex A, with all the stochastic models for the variables that we use in the calibration of partial factors. Very few words, I hope I'm in time, on the Part 2. Part 2 is for assessment, as we said. It's completely new. It has been a very long discussion. We inherited the work of WG2 with Thomas Lang sitting here, and we had to transfer this into the framework of basis of design. And this was a very long discussion. We ended up in April, so I would say yesterday, and the decision was taken to have this Part 2, covering the assessment of existing structures. It is not really a self-standing document. It has to be used together with Part 1, because many parts of Part 1 are still applicable to existing structures, such as combination or the use of the partial factors and so on. This is again covering geotechnical structures, so the assessment of existing geotechnical structures as well. This is not covering seismic verifications. This will be covered by Part 3 of Eurocode 8, as historically has been covered that. I really, it's impossible to summarize a very long discussion we had like this, but it's just to draw your attention on some spots. The first one is existing structure. The definition of an existing structure is a very simple question with an extremely complicated answer. We could not find a satisfactory definition valid for all the member states, because you understand that there are a number of legal implications on what is an existing standard structure. It has to be in use, it has to be transferred to the owner, who's the owner, by which act. So the definition is quite simple: any structure that physically, materially exists. But what is given is the possibility in the clauses in the main text of this document to add something in your national annex and to specify more details on what you think and what you define as an existing structure. And this is given here, you see, in the first red box. We have in these assessment methods both quantitative assessment methods, which is the main way to do and to perform the assessment according to the normal engineering practice that we use for new structures, but we also have some qualitative assessment methods which can be used in place of quantitative. This is again depending on the national annex, on the experience that you gain at national level for certain type of structures, for example, and can be used to assist the definition of the scope of the quantitative assessment method. So it's a set of methods which are offered as possibilities to the assessors. Important part that clearly the basic requirements for existing structures are not the same for the new ones. And in particular, they can be changed, the reliability targets. Typically, for existing structures, we can accept a lower level of reliability because the structure is existing, so it's already survived a number of events. But this is, again, clearly stated and clarified in the text. How to do that? The assessment needs to be done according to the partial factor method, so it's completely consistent with the experience that we have gained in the new structures. But there is also an opening not to prevent innovation, not to prevent deepening of the analysis, to the reliability-based method and to the risk-informed method. Clearly, there will be a restriction possibly in the national annex for that. Want to finish with showing you this flowchart. We'll not go into the detail of that, but you will recognize that the idea is that the approach for the assessment of existing structure is clearly a stepwise process. So we start from some preliminary activity, and then we go deeper and deeper and deeper if needed, and we can go out of the process if we think that the preliminary stages are satisfactory. And finally, if the outcome is negative, so if the structure is not fulfilling the requirements, the performance requirements, then what to do? Well, we have some general principles on interventions. which can be to nature, so constructional or operational intervention. And this is current practice, I mean. Constructional intervention, you can have the maintenance, if it is anticipated in the design, or rehabilitation, which is repair or upgrading of the structure, or even the worst case is demolition. And the operational cases, you can have, again, maintenance or the change in use to reduce the loads, for example, and make this acceptable. Thank you. Thank you very much for your attention.
I think the thanks goes to you. This was really a very informative talk, and just on time. Thank you for this. We will now have a look at actions on structures with Nick Malakatas.
Thank you.
The stage is yours.
Thank you, everybody. Let me also express my pleasure for being here and contributing in this workshop. Thanks to DIBt and Gerhard. Ladies and gentlemen, and dear colleagues here in this room, and so many of you connected online, I'll try to make a rather ambitious task, and you'll see what I mean, to present you the key changes and updates of Eurocode 1, which is a quite voluminous standard with a dozen of parts, as you see, and you know, of course, and mainly focus on actions and loads for buildings, bridges, and other civil engineering structures. You recognize imposed loads, self-weight, fire, snow, wind, thermal actions, execution, accidental actions, and the new parts, actions from waves and currents on coastal structures and atmospheric icing, and also traffic loads on bridges, crane supporting structures, and silos and tanks. So basically, except some update of the titles, we have achieved to create a sort of practical for all Eurocode 1 part, a common structure concerning the core content, mainly the design situation, the representation of actions, and the classification of actions. And as I just told, we have two new parts who have been based to the relevant existing ISO standards. And finally, we have improved the consistency with EN 1990 you have just seen presented by Paolo Formichi. So I'm afraid there will not be so many figures, but I will try to give you the most relevant information. For example, we have introduced some and clarified some notions like the tributary area, the area which is loaded and should be considered on the design. We have now a single table with all subcategories and subcategories of use for buildings, and similarly for the horizontal loads on partitions, walls, and parapets. We have some updates on the treatment of partitions like imposed loads, as it was already in the document, but we have made some changes, and we have also modified the two well-known formulas of the reduction factors alpha A to reflect the influence of the loaded surface and area, and alpha n to reflect the number of stories reflected. And the former Annex B has been removed. And we have also added, for example, an additional subcategory for garages and parkings, an additional category for roofs designed for helicopters, and subcategories of stairs and landings. All the rest is already said, is just a list of the parts that have an improved enhancement of ease of use. Now, coming to actions due to fire, we have improved we have clarified the scope, especially as far as the non-coverage is concerned. And there are three items. First of all, we don't deal any with sprinklers and active measures, neither on conditions of occupancy of building and fire compartments. And we don't deal with insulation materials, coating materials, and so on. Those are matters of products that's on the field. We have some new formulas and figures, as you can see, to allow for a simplified calculation of the fire, design fire. Now, in the annex, already existing Annex E, which is the annex on fire load densities, fire growth rates, and rate of heat release, we have the factors, the delta factors, who are describing and reflecting the different active firefighting measures. For example, the sprinkler detection, smoke detection, automatic alert transmission, the intervention of fire brigade, and so on, has been revisited. And when you find the time to look in detail, you will find a very comprehensive presentation. In the former Annex C, who dealt with local fires, we have extended this annex and added design models, virtual solid flame as a geometrical design model. And equally on Annex G, who describes the so-called configuration factor, which expresses the radiation of energy and the heat transfer, we have made some improvements. The most important, I would say, is the addition of a new Annex H, which is an informative annex concerning the thermal action for structural fires for timber structures, which combined with the Annex A of the fire part of for timber structures of VN 1995 will allow the design of timber structures for physically based design fires. Then I come to snow, and with this opportunity I have to say that it was Paolo Formchi himself who was the convener of the relevant project team and group. There are quite a number of additions in this part and renewals. Just as a reminder, the snow part of the existing, of the actual Eurocode has been based on a European research project in 1996. So you imagine there are almost 30 years, and also part of the European countries at that time were not part of the project. So there was a need for changes. Basically, the development of new models closer to physics and based on experimental data from the European climates, additional types of roof, additional cases, and specific models for snow local effects. We are using now the term balanced and unbalanced for snow and not drifted and undrifted, as in the ISO, the relevant ISO and American snow standard. The C exposure coefficient have been updated to take into account the snow load for locally sheltered area. We have a new model for the snow model for the pitched or gabbled roofs, And also for flat roofs, we have improved the approach by taking into account the size, the area of the roof. For very big roofs, I mean, it's not analogical. So we have to consider that, and we can also consider now, for example, the presence of solar panels or similar the presence of similar rows of tilted panels. We have some updates for cylindrical roofs and for domes with a model which is closer to the reality, but more simple than the ISO model. And for multi-span roofs, we have now make some corrections so that in the valley, so-called, between the roofs, the snow does not exceed the ridge of the roof. And finally, we have introduced also 2 more models concerning the taking into account of drifting of obstructions, and also the intersection of roofs. And just also another issue concerning buildings with different height, the one close to the other. We have now a much more close to model, much more close to reality, with 3 components. The one part for the load pertaining balance conditions, a second part to represent the sliding of from the taller roof to the lower roof, and finally the wind-driven accumulated snow, this part. So this is about snow. Concerning wind, we have made also some progresses in the sense that we have extended the scope, the coverage for buildings up to 300 meters instead of 200 until now. And we have a new formulation for determining the velocity and the mean velocity and turbulence up to 300 meters. As you probably remember, we used we had 2 methods for the so-called structural factor, CSSD. Now we have 1 single method. We have merged the 2 methods in Annex F, while in Annex H we have we address the vortex excited crosswind amplitudes, and also in Annex G. This is an annex devoted to the crosswind and torsional actions on susceptible buildings to torsional effects. We have also addressed the effects of atmospheric icing on wind, and we have added some clauses for silos and tanks. The most important thing is that the aerodynamic coefficients, the pressure coefficients, which used to be in the main text, are now transferred as normative, of course, as 3 normative annexes, C, D, and E, concerning pressures on surfaces, pressures across wall, and forces on structures. And we have added a number of additional cases, so we have a more extended annex. We have transferred from the actual part 3.1 of Eurocode 3 the part of wind, concerning the still lattice tower and guided mass. And we have 3 more annexes. One, Annex K, for the derivation of design parameters for wind tunnel tests and CFD methods, numerical simulations. Annex L, for the derivation of wind speeds based on meteorological measurements, and a short Annex M on probabilistic models. As far as thermal actions are concerned, there are not so many things that have been changed, only some updates and emerging of tables and redrawing of figures. An interesting new approach who has been added concerns the uncertainties related to the initial bridge temperature and to the range of this for structural members at the stage of completion of the restraint. So if we look at the next slide, you can see here it should be T0, and then delta T0 are express the uncertainties. And this is a figure for the maximum contraction and maximum expansion of the uniform bridge temperature. And this is the table where you can see the maximum and minimum uniform temperatures for bridge decks, steel, composite, and concrete. Now, concerning the part devoted to actions, to execution, we have made some progress concerning the delimitation of the scope of the field of application of the document as compared to the relevant existing structures, for example, standards, product standards for false wall scaffolding equipment drafted by the Technical Committee 53 and for auxiliary structures. We have improved the design CTS to be taken account, and we have added some aspects concerning imperfection, lateral stability, and dynamically applied actions. And the former Annex B has been removed. And last but not least, the former table 3.1, which is now the table 6.1, represents it gives a guidance for the determination of the characteristic values of climatic actions during execution. You will recognize the table. I mean, this is the typical case where you have a duration for more than 1 year, so you have the 2%, 1 every 50 years, 2% annual probability of the exceedance. In case you have a shorter duration, but more than 5 days, it's similar procedure, but you have to take into account the seasonal variations, while for very short periods, you have to rely on unreliable meteorological data. We have also offered, in a way, so to say, the possibility for the relevant authority to specify threshold value or a range of value. And this has some practical importance in some cases when the use of this threshold value has an impact on deciding whether to go on with the execution or not. There are few things changed in the concerning part 1.7 on accidental actions. One of them, as already presented by Paolo, is the Annex E, which is now compatible between the two documents. We have mainly, there have some additions concerning the impact of vessels, river, canal, and seagoing vessels, and the new impact formula for ship impact for the non-ice classed vessels. And there is an addition of a new Annex E, which I would say it's inspired by the existing German national annex, and refers to the JEBRIS. We have two new Eurocodes. The first one concerning waves and currents. The only, there is no, it doesn't make sense to compare because there are, but only with the ISO standard. The main difference being that the ISO standard, our part, it focuses on annexes, on actions, where the ISO standard was also a design standard. And ISO standard did not follow all the reliability framework and the partial factor method as in the Eurocodes. What we're doing. We have to frankly admit that it is not so much obvious to comply 100% with the reliability framework of Eurocodes for all types of coastal structures, especially for breakwaters. That is why we have introduced two more ultimate limit states, the so-called severe displacement of armored units and the severe overtopping. This is specifically for breakwaters, while as far as flood risk management is concerned, we have practically excluded this topic from the field of application, from the scope of the standard. Basically, the standard the core of the standard is the wave and current actions assessment and the dynamic conditions. And then, as you may see, there are various types of structures of coastal structures: cylindrical, mound, vertical face and composite breakwaters, coastal embankments, floating structures, and so on. And we have two important parts, one concerning the use of physical modeling in the laboratory tests, scale tests, and the other one, some additional specifications for reliability. The basic notions are, of course, the environmental sea conditions, the water level, wave conditions, height, frequency, and so on. The so-called dynamic estimate approach, which is related to the dynamic conditions and measurements, and the design approaches. I just saw one of the important tables where you can have the four design approaches, the classical semi-probabilistic with partial factors, then the probabilistic based on reliability, the risk-informed approach, and finally the approach based on measurements and tests. For part 1.9, we have two types of icing. The one is the glaze. You can see here the formation, the accretion model for glaze, and this is for rime. And we have a classification, the one based on the thickness and the other on the mass. I will finish in a couple of minutes, I guess. Concerning the traffic load part, which was a well-developed part, the main issue was the addition of the extension of the scope for the application of to other engineering structures, and essentially the geotechnical structures, where we have introduced two new sub-clauses, one for road bridges and the other for railway bridges, and are devoted to embankments and geotechnical structures. We have also issues concerning the track bridge interaction, noise barriers, etc. And the most important probably is the addition of a clause and a new Annex G concerning the vibration and generally the loading of footbridges. You can see here, for example, the classification of footbridges depending if you have a pedestrian strip group or a jogging group. And those are typical models for loading. 2 words for cranes. There are some additions and clarifications. The main improvement being the removal of the former normative annexes, which are covered by other annexes now, and the fact that we have now the typical bridge and gantry cranes, and their fatigue, their classification for fatigue is in a new Annex A, compatible with the crane design standard. In Annex C, we have added calculation for wall cranes, traveling wall cranes. And we have also a guidance for crane-induced actions for when we don't have any technical data. And finally, concerning silos and tax, we have a much more developed, better developed standard now. We have added sections on inverted silos with inverted crowns, with rectangular flexible walls, or symmetrical conical hoppers, overpressure factors, thermal differential causing pressures. And the basic differentiation is between the so-called fundamental load cases, which is symmetrical filling and discharge loads for various slenderness, and silo hoppers and bottoms. And finally, the special load cases, vertical walls, hoppers, and silo bases with unsymmetrical pressures, high slenderness, large eccentricities, filling load or squat immediately slow pipe flow, and so on. And finally, we have added, to enhance the use, a new Annex G with flow chart, which you can follow in order to apply the document. And this is a typical and important table where, depending on the slenderness, on the eccentricity, and filling or discharge, you can use choose the right eccentricity and the appropriate method for calculation. Well, thank you very much. I hope I did not spend much more time than. Thank you very much.
Stay with me, Mr. Malakatas. Thank you. I think we all understood it's a very complex standard. Thank you for presenting it in such a condensed way. I would ask all our colleagues to join us here at the table. I have one short info for our audience. For all of those who are following us online, we've been asked whether there will be a recording of this conference. Good news, yes, there will be a recording. And now, I'm skipping any intros. I think I'll give the floor directly to the public. I think we'll take a question from the chat first. And then my colleagues are already standing. Those in the room, please give a sign if you would like them to come to you and give you the floor.
Yeah, thank you, Carmen. First, on behalf of our online audience, I would like to convey the deepest gratitude to all of your speakers for your presentations. Yeah. And now I would like to turn our appreciation back to our online community. Thank you for all your active participation. So we received a tremendous number of questions now, and it's now my part to bring the best here to the table. So thank you for that. Now, don't waste time. We have a few questions for you, Steve. Yeah. It's about the timeline you mentioned already, but maybe you can explain how to find this information, when the second generation will come.
Sure. Well, I think it's probably important to draw this distinction between what's happening at a European level and then what happens at a national level. So really the key thing from a European level is that already the standards are going through their process. Some standards have concluded their process of formal vote and have been made available to national standards bodies. And as I said earlier, all of the standards will have, all of the second generation standards will have concluded their formal vote process and be made available to national standards bodies by early 2026. At a national level, really the information needs to come from the NSB, because different countries are going to be using different strategies for the transition between the first generation and the second generation standards, because the way in which that transition happens has to align with national regulations, and national regulations do vary. So I can't answer the specifics on what's happening at a national level, but perhaps it is appropriate for me just to mention that we are working in partnership with the European Commission's Joint Research Centre, JRC, and JRC have a fantastic website on the Eurocodes. People just need to Google JRC and Eurocodes and they can get to that website. And we will be putting more information around the program, and we've got videos that we're producing and various other resources that we'll be putting on that website. So that's a good place to go for further European level information.
Thank you. Thank you, Steve. Next question for you is about the aspect you mentioned, the ease of use. For instance, have you considered to provide some additional manual or handbooks? This is a big question.
Yeah. Look, and I think it's an important question, and it's a question which really gets to the essence of what is a standard for, and so obviously what we're seeking to produce in the standards are usable documents. But they are usable documents that serve quite a diverse set of different users. And it has always been, I think, our expectation, and this was true with the first generation Eurocodes, that it's very helpful to have companion manuals and guides. It is not the job of TC250 to produce those manuals and guides, but one of the things that we have done is that we have produced background reports to all of the work that has been done. Those background reports are, if you like, intended for the standardization community, but I think the information within them is going to be very, very helpful to people who want to produce guides or manuals.
Yeah, thank you. Thank you. Paolo, one question for you. There was a little bit of confusion about the two parts you mentioned, 1 and 2. I will read them out. The question, according to CEN website, the current standard of year 1990 and the previous one appears as withdrawn. You have named part 1 and 2, which are not on the CEN website, nor identified as primarily stage. Please, could you clarify the link between year 1990 and the two parts?
Yeah, spotted very well. As I said, we came to the conclusion of having this part 2 April. So it's really a recent decision. And now this is, as far as our subcommittee is concerned, that is decided, but now is in the hands of TC250 to take a decision on that with a new work item that has to be formalized. And this will be discussed, I think, very soon. And according to that discussion, we will get the alignment with the website of CEN with the two parts, hopefully, very soon. So, yeah, very good.
I think we have to commend our audience for their diligence and
yeah.
their familiarity with this. It's very impressive. But exactly as Paolo said, the process here is that Subcommittee 10 has made their decision and their recommendation for TC250. We are currently going through the process of voting on a new work item proposal. When that is concluded in the next month, then the CEN system will be updated accordingly.
We are up to date, and that's good. And I think we have the time for another question for you. It's about the consequence classes. Could you explain why consequence class 0 and 4 are not included in the tables with a minimum design quality level and the inspection levels?
Yes. As I said, the scope of the Eurocodes is covering consequence classes from 1 to 3. And the exclusion of consequence classes 0 and 4 is on purpose because we allow for CC0 to use some alternative provisions. So we do not want to cover fully CC0 in the Eurocodes. Eurocodes can be used, but alternative provisions can be used as well. And the same is valid for CC4. So the answer is the Eurocodes are still valid for CC1 to CC3. This is why the consistent presentation of all the provisions are for those classes. But the two new classes are, let's put it this way, introduced as a more defined boundary of what is the Eurocode core business.
Thanks. Nick, one question for you is a special question. I think is it correct not to evaluate wind and fire scenarios? For realistic CFD, it's computational fluid dynamic models, wind will influence the fire dynamics.
I'm not sure I understood the question. If the question is concerns the use of CFD in fire, this is one thing, and there are, I know that there are developed methods based either on standard fire or physical, natural fires. But I think you mentioned the combination of wind and fire. Yeah, I don't really see the point of this question. Yes, I'm sorry.
Maybe we can discuss later.
Fire is. We have also to remember that fire, although it's something very important and quite specific, is in a way it's considered as an accidental action as well. Yeah. So it's.
Okay. So I will.
I
give
would
back to you,
actually like to give one question at least to the room. Are there any hands raised?
So
yes, there's a question at the back, Inga.
Thank you. I'm Dirk Brandenberger. I also work here at the DIBt in Berlin. I'm not working as a structural engineer anymore, so I'm out of field for a long time. But one question regarding to wind loads occurred to me when I heard it, which might have been solved already. A number of years ago when I was working in the field, there was always a problem with wind loads for temporary structures, summer, winter, or maybe in the city, you know, like you have big drafts with high-rise buildings, so the standards didn't really give me any good models for that. So we had special data to be raised to actually prove certain wind loads for start. Is there in the new standard like provisions in for like wind loads in the city with high-rise buildings, you know, having higher wind loads, or temporary structures, you know, which stand for 2 years? Is there any development?
Concerning, if I understood your let's say, wondering rather than questioning it. Concerning temporary structures, we have, how to say, actions on them in part 1.6, and there are also issues of combination of actions taking into account wind. Now, first of all, one has to see whether in that case the design is according to Eurocodes in general and then follow the Eurocodes, or whether it is a case where the product standard for temporary structure is applied. This is the basic decision to be taken by the designer. Now, if you apply the Eurocodes, I'm not sure I have understood the question raised. I mean, the issue raised.
But Nick, I think on yes. That, I think you showed the table that talks about the treatment of like for short duration, short life structures.
Yes. Is that about that?
So I think that
you might have other peaks.
Temporary structure.
Okay,
because
is it feasible to take like a wind load which occurs every 100 years, for example, if your building just stands for 2 years? The other thing is, you have like roads which are just 10 meters apart. So basically, is it reasonable to say a wind load is just? Oh, sorry,
I think.
I got carried away.
I think yes. You mentioned temporary structure, and I thought about. Okay.
Yes. Please hold the handheld very close to your mouth.
Just a word about that. I think it's up to the designer to make, let's say, a sensible and rather cautious. Because when you say less than 5 days, well,
5 years.
5 years is other thing, but less than 5 days, for example, or when we're talking about the seasonal effect, will the design be, will the execution follow the design as far as the season is concerned? So you have, as designer, to take some decision on that. But if you take the decision, you have the means to follow the relevant guidance.
Sure. Thank you.
I think it's perhaps worth just noting as well, I think one of the things which you will have seen a little bit today as well when some of the clauses were put on the screen, that one of the changes between the first generation documents and the second generation documents has been that we've recognized that there are certain matters that are really appropriately determined at a project level and agreed between the relevant parties for that project. And in the first generation of the Eurocodes, those circumstances were expressed in a very inconsistent manner. Whereas in the second generation, we've tried to do that in a much more consistent manner. And we've also looked to acknowledge the fact that in certain circumstances, that the decisions that might be taken at a project level will be influenced by the requirements of a national authority or relevant authority. So we've got a common formulation that explains how those project-specific circumstances should be dealt with, and we've looked to make that much, much clearer and be very clear around the hierarchy of authority for making those decisions as well.
I understand. So basically you're saying we formalized what we used to do in a project with bigger discussions, there'll be a formalized way in the future. That's good.
Yeah.
Thank you.
So we see there will be a lot more technical discussions during the break, I think. Thank you all. I'm closing this session.
Thank you.